last operation I need to do on this aluminium casting now is to drill out and thread this portion here. This is going to have a brass fitting which will take the media and the air that's been drawn in through the metering valve up to the blast media gun. And because this is still unmachined, it's just a rough casting, and this was cored when the casting was made, I need to get an accurately drilled hole in that and put a thread in it as well. Also I want to machine off that end just to make it look tidy. So I've given that a rough file and just get rid of the casting line. And I've got a probe here, and what I'm going to do is probe the center of that hole. Even though this is a rough casting and that is not likely to be super accurate, it's going to allow me to drill out that cored hole without the drill snagging and pulling to one side. So I'm sort of less interested in the outer diameter and more interested in this inside diameter. So I'm going to go ahead and put the probe down into that hole. And we're going to run a probing operation here and see if we can find that center. Okay, so that's set my X and Y at 0, and what I'll do now is I'm going to swap over to a fly cutter and we'll machine that end. Alright, so we've returned to 0, so I can swap out now for our drill bit. So tapping size I want to use here is 14mm. I'm going to cut an M16 metric coarse thread there. Alright, now as that drill down deeper, it was entering the tapered section, and I could hear that it was actually it had stopped cutting. So we've, by pure chance, we've met up with the conical section and that diameter drill bit, which is a good thing. So I don't want to step there. So I can swap out now, we'll put the 16mm tap in there, we'll get the thread started at least. It's worth noting here too that when I put this casting in this vise, I've got a shim of copper on the moving jaw just to take up any irregularities in the shape of that aluminium casting. So we're getting good grip on that. That was my one fear, that this was going to move around in the vise. Alright, that's enough. I'll get a big tap wrench on that to finish. Alrighty. See, there's my piece of copper that I used when I tightened that up. Okay, so we've got a partial thread in there now. I'll just finish that off. Alright, that should do it. And I use my second biggest tap wrench to do that. I don't want to show off or nothing, but I have got an A-bomb size one. Well, I'm sure he's got one that's bigger. That's better. Last thing I need to do here is to make a fitting which connects the clear plastic tube from the metering valve and going up to the hopper itself. So I've got some hex stainless steel. This just came out of my scrap box, and I'm not sure what grade of steel it is, but man, it's hard to turn. It's really tough. But being stainless steel, it's not going to corrode, and it's probably going to be a bit more wear resistant. So we'll use this. It's an awkward thing to machine. I've got to machine the part that takes the tube, which includes a little raised lip around this edge, and that means that when you flip it around to cut the thread, it's really awkward to hold. So what I'm going to do is sort of drill it last. I'll put a center drill in this end. I can machine most of the fitting that takes the tubing, turn it around, cut the thread, and then we can flip it back again, grip it by the hex, and just drill it through. At least that's the plan anyway. I hate that. I just can't get this machine to run fast enough for the chip breaker to work. Okay, I'm going to cut this off and then we'll flip it around, cut the thread. Okay, got 2mm pitch, everything's set up. Give it a go. Alright, very close. Okay, that's good enough. I'll take the crests off those threads and we should be done. Sweet. Alright, it's firm. A bit firmer than I'd like. But once again, this is a one-time only deal. We'll tighten this up, should never have to do it again. Okay, we flip this around and just finish off the undercut for the tubing. And we can drill our through hole. Let's just give some resistance when the tubing slides over there and we tighten down with the hose clamp. It'll just stop it blowing off, or not that there's any pressure in there. Okay, we'll drill our through hole and we're done. Well, do you want to hear a sad story? This is the second one of these I had to make. Here's the first one, and you can probably guess what happened here. But I was running my last drill bit through, which was 13 millimeters diameter, and it turned out my thread relief was also 13 millimeters diameter. So when the drill bit got to that portion, it just snapped the thread off. But there you go, that's why we can't have nice things, Mark. So I'm going to leave it with this diameter drill bit in the fitting, and we'll try it out. And my reasoning originally was that I wanted the maximum diameter bore that I can get here, so I can also get the maximum amount of blast media and air through this fitting. If there's a bottleneck here, then all the blast media is going to jam up at this point. But we'll try it out. I can always come back and re-drill it sort of bigger. Well, here are all the components of the metering valve, and I haven't tried this out yet, so we'll get it assembled and get it in the cabinet. So this is the plug that keeps the media in the hopper. If you ever want to change the media, you can just unscrew that and drain out the media that's in there. I didn't bother with a washer or a seal there. I'm pretty sure nothing's going to leak out of that. The fitting that takes the blast media and the air to the inside of the cabinet is threaded in there, and I put a fibre washer on that one. But once again, I can't imagine that there's going to be any leakage. We're dealing with a... That was my compressor. We're dealing with a slight vacuum in this area here, so given that we're deliberately leaking air into this stream of blast media, I can't imagine that's going to be a problem if it leaks. Now the adjustment valve itself, I've got a copper washer on that one. No particular reason, I just happen to have one the right size. And once again, if a little bit of air leaks in there, it's not an issue. Okay, so this is ready now to fit to the bottom of the hopper door. Now if you're wondering why that's offset there, it's because I did all the modelling for the casting of this upstairs, and I didn't have the machine handy to verify any measurements, and it all looked right. It was called eyeball engineering, looked okay, but when I came down and tried to fit it, I realised that the adjustment screw on the metering valve was going to foul this door unless I offset it like that. Now, as it turns out, it's not really an issue. As long as I can get to the adjustment screw, that's all we need. And I put a steel washer there, and when I tighten this nut down, it's going to compress that rubber seal that's already there. If I had the right size spanner, I'll be back. Okay, that's ever going to be really, really tight there. This foam is quite spongy, that's the problem. Okay, so we're all ready to give this a run. So I'm going to fit this to the cabinet, we'll get the blast meter in there and we'll crank it up. Well, here is the metering valve in place, and I have used it, and I'm sure you're all dying to know, does it actually work? Well, yes and no. And I'm going to try to demonstrate now what it looks like using the original concentric tube pickup that was supplied with this blast cabinet, and then we'll have a look at the metering valve and just see what difference we get. So bear with me, we're going to try and look inside the blast cabinet using the original setup. Okay, well, I've got the pickup tube as it's supplied pushed down through that mesh there, and it's a very awkward way of doing it. There's no point where you can seem to attach it where it doesn't get in the way, and we're going to try and look at this running from the outside. I can't do it here because we're going to get dust blowing back at us, but I want you to watch as the blast meter comes up this tube and just see whether we get a continuous supply or not. Now, in fact, you don't. What you tend to get is little bursts of blast media coming up in fits and starts, and when you try to do a large job, it just takes 3 to 4 times longer because you're only getting this intermittent supply of the blast media. I've got my pressure set to 80 psi, and where are we? Here we go. I want you to keep your eye on what happens with this tube here. God, that's hard. I'm trying to trace. I'm going to do everything in reverse. Anyway, just watch as the blast media comes up this tube here. Now I'm just going to do this, and what you can watch because my compressor is going to cut in and it's going to be really noisy. Okay, so here we go. Not sure if you can see that clearly, or I can hear it. It's coming up in in dollops, if you like to call it that. And I'm guessing for about 1/5 of the time there's media being delivered. For the other 4/5 of the time you're waiting, there's just air. So in my view, that's a big fail. That's not really an efficient way of doing things. I'm using 60 grit garnet, and like I say, 80 psi pressure. I'm using the standard gun that came with the blast unit. I haven't modified that in any way, and as far as I can tell, I've set everything up the way it was meant to be done in the manual. So now let's change over to using the metering valve and see if we get any difference. Okay, this time we're looking on the outside of the cabinet. This is the clear tubing coming from the metering valve. It's going up and being delivered to a union that goes through the wall of the blast cabinet. And this dark line you can see here is the level of the garnet at this stage. Now when I start the air supply to the gun, just watch what happens as that garnet starts to move up that tube. Okay, now I'm sure you're all saying, yeah, that was a complete failure, and that's what I was thinking too. But what I've got fitted to the gun at the moment is this smaller ceramic nozzle that came with the kit. Now it's 4.75 roughly millimeters in diameter, and I'm going to swap over to a bigger bore ceramic nozzle. This one is stamped, that's stamped 6, but it's actually around about 7 millimeters bore. And let's just see what difference that makes. Okay, so you'd say, all right, well, that's not much of an improvement, but it is. It's about half the time delivering media, the other half time just blowing air. And what you would have noticed is that it sucks up the media, it delivers that continuously for a period, and then the flow breaks and just drops back down the tube, and it repeats that cycle. Now, I've got the valve on the metering valve, the actual opening, as wide open as it will go. I've even taken the screw out of the metering valve altogether so that it's got a wide open bore and it can suck in as much air as it wants, and it's still not giving me a continuous flow. Now, I'm starting to suspect the actual gun itself. I'll show you what I mean. Now, this is the gun that came with this particular unit when I bought it, but I already had one of these. I purchased one years ago and I was using it without a blast cabinet. I was just doing it out in the open air. And I swapped out the guns and found that there was a difference. Even though physically they look identical, one seemed to work better than the other. And then I started to wonder whether it's the actual design of the gun that's the problem. Now, if you look at what Tacoma offers as an upgrade for this Harbour Freight or Hare & Forbes sandblasting cabinet, they supply a different style of gun altogether. And I was wondering, maybe there's a reason for that. And all the videos I watch on YouTube about upgrading these cabinets, most people have actually purchased the whole Tacoma kit, including the foot pedal, the replacement gun, and also the metering valve. And most people have reported that they can get a better result with a lower pressure. So, having said all of that, now I'm starting to wonder whether I should just upgrade this gun as well. And in fact, that's what I've already started to do, and I'm about 3/4 of the way through that process. And you're going to see, upcoming video how I've gone about that process. And you may have heard me mention that I tried to buy this upgrade kit from Tacoma and I failed, and I decided that the only option was to make my own. And just this morning, one of my regular YouTube viewers told me that you can buy the replacement gun and a metering valve, although not the same as the Tacoma kit. You can buy these from Hare & Forbes, where I purchased this sandblasting cabinet. So now I feel like a complete idiot. I went to Hare & Forbes to buy this unit. I walked around for about half an hour, 3/4 an hour, looking at all the stuff that I'd love to own but can't afford, and not once did I see the metering valve or the replacement gun for this unit. And in fact, even on the website, when I actually bought this via the website, but I went and picked it up in person, once again I didn't recall seeing that you could buy these upgrades. But at the end of the day, I like making things. I like the idea of setting myself a challenge to see what I can do. So I don't sort of regret that I went down this path. Anyway, check out the next video when it comes out. It should only be a couple of days now. And just to give you a little bit of a teaser, these are the 3D printed patterns for the replacement gun and also the core box to make the cavity inside this gun. So check it out when it comes out. It's full of fun and surprises, trust me. Okay, that's all for now. Thanks for watching.